Hello viewers, in today's class we are going to discuss yet another important problem from definite integrals, right? So in this lecture we'll learn how to find the values of this type of definite integral using the concept of Laplace transform, right? So in this lecture we'll see how easily we can solve these type of integrals by using one important property of Laplace transform, right? So let us start. So before proceeding further, let us quickly see the definition of Laplace transform of a function, right? Now see, suppose we have a function, say f of t, right? And if we want to write the Laplace transform of this function f of t, then the Laplace transform of f of t is given by this integral, that is 0 to infinity, and we have e raised to minus st, and here we have f of t dt, right? So this is the definition of Laplace transform of a function f of t, right? So here to evaluate this integral we are going to use straight away this definition, right? So now let us first call this integral as I, right? Okay, now see, let us see this structure of this integral, right? Now see, if we write this integral as I is equal to 0 to infinity, and if we write it like this, that is e raised to minus st and t sine t dt for s is equal to 3, right? So if we consider this integral, right, so here we can differentiate these two integrals by writing this integral as I1, right? So if we suppose, or if we let this integral I1 as 0 to infinity e raised to minus st t sine t dt, and for s is equal to 3, this integral I1 reduces to our original integral I, right? So what we have done here, if we wish to solve these type of integrals, then what we usually do, see here we have a term e raised to minus 3t, right? And apart from this term e raised to minus 3t, we have t times sine t, right? So if we take t sine t separately here, and e raised to minus 3t can be written in general as e raised to minus st, right? And if we take the particular value of s as 3, then I1 reduces to our original integral I, right? So whenever we solve these type of integrals, we always write the integral in this form, right? So we introduce a parameter s in the integral, in the given integral I, right? So why we have introduced this parameter s? Because see, the definition of Laplace transform of f of t goes like this: 0 to infinity e raised to minus st f of t dt, right? So now if we compare this integral with this one, then see here we have e raised to minus st, right? And for f of t we can write this function, right? So here we have f of t as t sine t, right? So now if we compare this integral with this one, then we can readily see that I1 is nothing but the Laplace transform of this function f of t, right? And we can now write this as Laplace transform of t sine t, right? So here the basic concept is to convert the given integral in terms of Laplace transform of some function, right? So here we have e raised to minus 3t and t sine t, right? So we'll write this integral as the Laplace transform of t sine t, right? Okay, so now to find out the value of this integral I1, we have to find the Laplace transform of t sine t, right? And in order to find out the Laplace transform of t sine t, we'll use one very important property of a Laplace transform, right? So let us first quickly write that property, and then we can readily apply that property to get the value of I1. So now see, we have an important property of Laplace transform, that is, if we have a function say t raised to n f of t, then the Laplace transform of this function t raised to n f of t is given by a minus 1 raised to n, and the nth derivative of the Laplace transform of f of t, right? And if we write the Laplace transform of f of t as capital F of s, then here we can write capital F of s, right? So the Laplace transform of t raised to n f of t is given by minus 1 raised to n, and the nth derivative of the Laplace transform of this function f of t, right? And now see, here we have to find the Laplace transform of t sine t, right? So if we compare t sine t with this one, then we can see that the value of n is equal to 1, right? Because here we have t sine t, right? And the value of n is equal to 1, right? So if we apply this property to this function t raised to 1 sine of t, then we can write minus 1 raised to 1. Here we have n equal to 1, and f of t is equal to sine of t, right? So we have minus 1 raised to n, and the first derivative, because n is 1, so we have the first derivative of the Laplace transform of this function f of t, right? So we have f of s, so minus 1 raised to 1 is minus 1, so we have d by ds of f of s, and f of s is the Laplace transform of f of t, right? So here we have Laplace transform of f of t. It implies that we have to find the Laplace transform of sine of t, right? And now we know an important result, that is the Laplace transform of sine of at is given by a divided by s square plus a square, right? And see, here we have to find the Laplace transform of sine of t, right? So if we take a is equal to 1, then the Laplace transform of sine t is given by 1, taking a is equal to 1, so we have 1 over s square plus 1 square, that is equal to 1 over s square plus 1, right? So now we can write minus d by ds of the Laplace transform of sine t, which is 1 over s square plus 1, right? So now we have to find the derivative of this function 1 over s square plus 1 with respect to s. So now let us find out the derivative of 1 over s square plus 1 with respect to s, right? So we can now write it like this: d by ds of s square plus 1 raised to minus 1, right? Okay, so now here we can easily find out the derivative of s square plus 1 raised to minus 1 with respect to s. So we have minus 1, then we have s square plus 1 raised to minus 1, and then by chain rule the derivative of s square plus 1 is equal to 2s, right? So now see, minus and minus becomes plus, and here we have s square plus 1 raised to minus 2 times 2s. So that is equal to 2s over s square plus 1 raised to uh, power 2, right? So the value of this integral I1, which is equal to 0 to infinity e raised to minus st t sine t and dt, is equal to 2s over s square plus 1 raised to power 2, and we can see that I1 is a function of s, right? Okay, so now see, with the help of this result we can easily find out the value of our original integral by taking s is equal to 3, right? So if we take s is equal to 3 in this integral, then I1 becomes equal to I, right? So the value of I can be obtained by taking s is equal to 3 in this expression, right? So we have 2 times 3, then we have 3 square plus 1 whole square, so this is 6 divided by 9 plus 1 square, that is equal to 6 over 10 square, and that is equal to 6 over 100. And if we simplify it, so we have 3 over 50, right? So viewers, the value of this integral I is equal to 3 over 50, right? So in this way we have seen that by making use of the concept of Laplace transform and this property of Laplace transform, we can easily solve these kind of integrals, right? So using this result, we can find out the values of these kind of integrals, right? So for instance, let us take this example. Suppose we have to find the value of this integral 0 to infinity t times e raised to minus 4t sine t dt, right? So now if we compare this integral with this one, then we can easily see that we have t sine t and e raised to minus 4t. So the value of s is equal to 4, right? So the value of this integral can be calculated directly by putting s is equal to 4 in this result. So we have 2 times 4, then we have 4 square plus 1 whole square, so this is 2 fours are 8, and this is 16 plus 1 17 square, that is 8 over 289. The square of 17 is 289, right? So the value of this integral is 8 divided by 289. Now let us take one more example. Suppose we have to find the value of this integral, right? So if we compare this integral with this one, then we have t sine t e raised to minus t, right? So the value of s is equal to 1, right? So taking this value in this expression, the value of this integral is equal to 2 times 1, taking s is equal to 1 in this result. So we have 1 square plus 1 whole square. So this is 2 divided by 1 square is 1, 1 plus 1 2. So we have 2 square, so this is 2 over 4, that is equal to half. So the value of this integral is half.